Okay, let's go over the Solid Geometry 1 homework because some of these questions were straightforward, some of them were challenging. So let's take a look. Let's do all of them. Number 1, a fish tank in the shape of a rectangular prism has dimensions 14 inches, 16 inches, and 10 inches. The tank contains 1,680 cubic inches of water. What percent of the fish tank is empty? Okay, well, before we deal with our algebra topic of percents, let's figure out what the volume is. Well, we've discussed that the volume of a rectangular prism, the formula for the volume of a rectangular prism is length times width times height. I like to make a little table, as you all know. And here we have really actually doesn't matter where we put these in because we're just going to multiply them and we get our volume is going to be just the product of all of the dimensions. They're all in inches, so there's no right there. And that's going to give us a total volume of 14 times 16 times 10, which is 2,240. And this is in inches. You can just write inches cubed, right? Well, that is the actual fish tank. However, there is 1,680 cubic inches of water already in there. Well, what percent is empty? Well, obviously, to figure out the empty amount, the empty volume, we're just going to take the total capacity and subtract what water there is in there. And when we subtract that, we get 0 and 6. And it's going to be 11. So it's going to be 5. So we get 560 cubic inches of emptiness. Well, it says what percent of the tank is empty. Well, you need to remember back in middle school and in algebra that when you're dealing with percents, it's really just kind of the part over the whole. So if we want to know what the percent that's empty, we're going to say, well, 560 cubic inches are empty out of the total capacity of the tank, which is 2,240. Now, when we divide that, we're going to get a decimal, and then you just multiply that by 100 to get your percent. So it's going to be 560 out of 2,040. Oh, look at that. And just multiply that by 100 just to see the answer nice and clear. There is exactly 25% of the tank is empty right there. That wasn't that bad, now was it? All right, this one right here, I think some of you might have not been that fond of. All right, I understand why. Because we're talking about the surface area of a box, the surface area of a rectangular prism. And the surface area has this unfortunate formula of being 2 times, remember, the length and the height, plus 2 times the width times the height, plus 2 times the length and the width, right? So that's the formula. It's pretty lengthy, lots of letters, lots of variables. And as always, I like to make a little table. The table really helps me organize my information, makes it a little bit easier than it might be otherwise. It's what's given to me here. Well, they actually give me the entire surface area. Well, that's helpful. 204.25. There, if I look at the picture, I can decide that that 10 feet will be my length. I could decide that that 6.5 is going to be my height. And if I mix those up, it's actually not that bad. And it's the width that we're looking for. So they have it as X. I might as well keep it as X myself. And now all I'm going to do is substitute everything into the formula. If I only have one variable at the end of the day, I should be able to solve it with straightforward algebra. So my surface area is 204.25. And then I'm just going to do this. Watch. I'm going to go 2 parentheses, parentheses, plus 2 parentheses, parentheses, plus 2 parentheses, parentheses. That helps, sets me up for a really simple substitution here. Well, my length and my height, I got 10 and 6.5. This one's going to be my width and my height. X and 6.5. And the last one's going to be my length and width, which is 10 and X. All right, it's coming together here. So let's see if we can simplify some of these products. Well, I can do this one in my head, I think, because 2 times 6.5 is 13, and 13 times 10 is 130. And I can do this one in my head too. 2 times 6.5 is 13 times x is 13x. And this one's easy to do in my head. 2 times 10 is 20, 20x. All right, now it's looking like something I can handle. All right, so let's continue to, well, I'm going to do two things at once. I'm going to bring the number to this side and combine my x's on the other side. So this side I'm going to have 204.25 minus 130, right? Because I'm going to bring this over to the other side because they're both numbers. And I'm going to combine my x's on this side, which is going to be 33x. Now, as to not make any silly errors here, which I don't want to do, I'm going to say 204.25 and use my calculator to subtract 130. And that gives me 74.25. 74.25 is equal to 33x. And of course, the last step would be to divide both sides by 33. And x will be equal to, drum roll please, 74.25 divided by 33 equals 2.25. 2.25, in this case, feet. Oh, look at that. It's right there. Excellent. And there you have it. That's how you solve a missing variable surface area rectangular prism problem, right? Looks more complicated than it actually is. Number 3, if the surface area of a cube is 110.94 feet squared, what is the volume of the cube? All right, this is kind of the reverse of what we did in our first lesson. They're talking about a cube, they're talking about the surface area, and they're talking about the volume. So I'm going to write both formulas out here. I'm going to say that the surface area of a cube is 6 edge squared. And the volume of a cube is edge to the third power. Right? Two formulas that you can have written down in your formula sheet, not an issue. Well, this here has surface area and edge, the only two variables that are involved, and this has volume and edge. Right? So if I know the edge, I can figure anything out. But what's given to me in this problem is the surface area, 110.94. Well, I'm going to substitute that into my formula over here, and I'm going to get 110.94 is equal to 6e squared. So I just got to solve for e here. Well, the first step will be to divide both sides by 6. And I'm going to get e squared, because that's going to cancel out, is equal to, no, I can't. I'm not going to do that in my head. I'm going to make sure I get the exact answer. 0.94 divided by 6. And that's 18.49. 18.49. Well, in order to get to the last step, I got to get rid of that squared. So I'm going to square root both sides. And I'm going to get e is equal to, what am I going to do here? A little trick. I'm going to do second square root, and then I'm going to just do the answer, and the answer is in blue here above the negatives. I go second negative, right? It's a little trick that some of you might know. And I get 4.3. Okay, well, the edge of my cube, right? We can imagine we have a cube here, right? And now we know that one of our edges is 4.3. Well, because it's a cube, all of the dimensions are exactly the same. So I'm going to put it over here, 4.3, and then just substitute that into my very simple volume formula, and I'm going to get my final answer here. I'm going to get 4.3. All I got to do is raise that to a third power. Well, you could just go power 3, enter. And that's going to give me 79.507. Oh, look at that. That's an exact answer right there. Perfect. All right. This isn't so bad. Number 4, if the length of one side of the cube is 2 pi to the third, that's weird, having pi as the length of a side, but hey, they're giving it to us. What is the surface area of the cube? Well, the length of one side of a cube means all the dimensions are 2 pi to the third power. I see the word surface area, I see cube, so I say surface area of a cube is 6e squared. So really, I'm just going to ignore all of that weird pi stuff and just substitute it right in. If they tell me it's the edge, I'm going to adjust them. It's 2 pi to the third power, right? That's the length of one side. I wish they called it an edge, but they didn't. To the second power. All right, well, here is something that's interesting. Well, we're going to take 2 pi to the third power and raise it to the second power. Well, and you can see all the answers are in terms of pi. So you can't just put that in the calculator. But you do have to remember something. When you square, well, this coefficient is just going to be a normal square. 2 squared is 4. But remember, when you take anything to a power, you actually multiply those. So it's actually going to be 4 pi to the 3 times 2 to the 6th power. And then finally, when we multiply that, it's going to be 24 pi to the 6th power. That's going to be your surface area. 24 pi to the 6th power. There it is right there. 24 pi to the 6th power. Okay, oh, another one where they're giving us the side with pi. Interesting. And you can tell these are old Regents questions by the font. All right, the volume of the box in the diagram below is 40 pi to the third power cubic units. Can you find the length? All right, finding a missing dimension with volume is easier than actually with volume than it is with surface area. So I see volume and box, and I can see that the box has different dimensions. So it's not a cube, it's a rectangular prism. So the volume is equal to length times width times height. I always go through this process. It's really helpful just to make your table and get the information as it's given. 40 pi to the third is the volume. The length I'll say is 5. The width I'll say is 2 pi. If you mix those up, it actually doesn't matter because it's just multiplication. And we'll say the height, which actually it is if you look at the picture. Well, let's get everything plugged in here. The volume is 40 pi to the third power. And then I'm just going to do one of these things that I like to do. Well, the length is 5. The width is 2 pi. And the height is really what we're looking for, which is x. All right, well, let's see. 40 pi to the third power. Let's simplify this. 5 times 2 times 1 is 10. And pi and x multiply, so it's pi x. And what we're doing here is we're solving for x. So let's divide everything else out. Let's divide the 10 pi out of there. And divide this side by 10 pi. Well, we're going to get x is equal to something. Well, numbers divide normally. 40 divided by 10 is 4. And then you need to remember that when you divide exponents, you subtract. And if there's no exponent for this pi, it's like pi to the first power. So it's going to be 3 minus 1, which is pi squared. So x will be 4 pi squared. Oh, there it is right there. Surface area. This is just straight up surface area. You have the formula right in front of you. All you need to do is plug these in, right? The surface area is equal to 2LH plus 2WH plus 2 length width, right? And we're looking for surface area, so we really just need to have our length, our width, and our height. And you can see the length is 4, the width is 2.5, and the height is 2.5. Right? Don't get that confused. So here we're really just calculating that our surface area is equal to 2 parentheses parentheses plus 2 parentheses parentheses plus 2 parentheses parentheses, and let's just substitute those in. My length and height is 4 and 2.5. My width and my height is 2.5 and 2.5. My length and width is 4 and 2.5. So now you really just need to put that all into your calculator and hit enter. That's really all there is to that. So it's 2 times 4 times, I don't even need to put the parentheses actually, 2.5 plus 2 times 2.5 times 2.5. Hopefully I don't make a mistake putting this in here. It's hard with my keyboard. 2 times 4 times 2.5. Enter. 52.5. The surface area should be 52.5 centimeters squared. Remember, surface area is two-dimensional. Oh, there it is, 52.5 right there. Ooh, this one. This one I remember when it came onto the Regents here. This was a long time ago. All right. Tracy has 2 empty cube-shaped containers with sides of 5 inches and 7 inches, as shown in the company diagram. She fills the smaller container with water and then pours all the water from the smaller container into the larger container. How deep? To the nearest tenth of an inch will the water be in the larger container? Interesting question. All right. Well, let's go back and break this down. First of all, filling three-dimensional figures with water, that's the essence of volume, right? So this is a volume question, obviously. All right. And it's a cube. They're both cubes. So quite simply, the volume of a cube is your edge to the third power. So I'm going to start with that. And they tell us that she fills the smaller one completely. So why not find out exactly how much water we're dealing with in the smaller one? And we could see that the edge is 5 inches. So some of you might even be able to do this in your head, because when you take 5 inches to the third power, it's 5 times 5 times 5, which is 125 cubic inches. I like to write inches cubed. So our volume here that we're dealing with is 125 inches cubed, cubic inches of water that is coming from this smaller cube, and that's going to be dumped into this larger cube. And the question is, how deep is the water going to be to the nearest tenth of an inch? Well, this is a cube too, right? It says they're both cubes, which means this is 7, and this is also going to be 7. However, you might also be able to imagine that obviously we're not going to fill this all the way up. So it's not really good. The shape that the water takes won't really be a cube anymore. It'll be a rectangular prism. And what the question is asking is that when you take all that water, it's going to get to a certain level here. And that's really what they're asking for. So they want to know how high, how deep the water is going to be. So that's really our X, how high the water is going to be when it's dumped into this larger cube. So we can treat this like a rectangular prism and say, okay, well, the volume for that is really going to be length times width times height. And if we keep the height that we're looking for as our X, is what we're looking for here, we know that our length and our width are both going to be 7 and 7. And we know that the amount of water is 125. So now we could just substitute this into the rectangular prism formula, which is 125 cubic inches of water. We'll definitely have a length of 7 and a width of 7, but how high is it going to get? That's really the question right there. It's going to be 125 is equal to 49x, divide both sides by 49, and that's going to give us our answer right there. It's going to be 125 divided by 49. So 125 divided by 49. It's going to reach a height of, to the nearest tenth, 2 point, be careful, it's going to round off to 2.6 inches. 2.6. 2.6. Yeah, I remember that one. That was a good question. As was this one. Well, this one was a little tricky, actually. This one, maybe a little too tricky. All right, another regions question. As shown in the company diagram, the length, width, and height of Richard's fish tank are 24 inches, 16 inches, and 18 inches, respectively. Richard is filling his tank with water from a hose at a rate of 500 cubic inches per minute. How long will it take, to the nearest minute, to fill the tank to a depth of 15 inches? Oof. Well, this I don't like for a couple reasons. Well, first of all, you got to be really careful when calculating the volume of the water. They're giving us the dimensions of the tank, not the water, but it's the water we have to be interested in. And it says that it's not using this whole 18 inches. It's stopping right there. You see that? So while it's 18 inches to the top, we got to kind of throw that out and just substitute that with our 15 when calculating our volume of the water. So let's start there. So this is obviously a rectangular prism. So it's just as simple as length times width times height, right? I'm just going to go right to it since we have a bunch of parts here. I'm not going to make my table here. I'm just going to say, well, let's see how much water we have. Well, it's going to be 24 times 16 times 15. Oh, they really are getting nitpicky with that right there. So the volume of the water in this case is just going to be 24 times 16 times 15, which is going to be 5760. 5,760 cubic inches of water. Well, if we know that that's how much water is being pumped in here, and for every 500 it takes a minute, let's see how many times 500 goes into this volume. For every 500 of it, it's going to take 1 minute. So we're going to take that volume and divide it by 500. And we get 11.52 minutes. But it says to the nearest minute. Well, we're going to round that up, and we're going to say 11.52 rounds up to 12 minutes. Alrighty, we're getting there. 2 more questions. Well, find the volume of the prison. Wow, this is as easy as it gets. They save the easiest for last here. I'm not even gonna write the formula here. They give us all the dimensions. It's going to multiply the length times the width times the height. I guess the only thing difficult about this question is that it has a fill-in rather than multiple choice. 8 times 3 times 2.5, which is 2.5, is 60. 60 cubic inches. And then finally, this one was kind of tricky. Tony has an empty room in his house. The length of the room, so looking down at the floor, the length and the width are 8 by 8, right? The length of the room is 8, the width is 8. The height is 10. So he wants to wallpaper just the 4 walls. So you really have to do a little bit of a visualization here. How many square feet of wallpaper should he buy, right? Don't worry about windows or doors. So you really have to just kind of visualize that, you got this floor space right here. The floor is 8 by 8, but the walls, go up 10 feet, and there's 4 of them, right? This one goes up 10, right? It's hard to draw. Well, so each wall really has a dimension of 8 by 10, and there's 4 of them. So you got to be a little tricky in this one, right? Because it's like you're inside kind of a rectangular prism room, but you got to visualize that the floor is 8 by 8 and the height of the wall is 10. So each one, quite simply in your head, each wall is 80 square feet. Well, and there's 4 walls. So it's going to be 4 times 80, which is 320 square feet. I just kind of did that one in our head, kind of. Alrighty, so there is the homework, which was a little bit tricky, I admit, but hey, we only have a couple more classes. We gotta jump to Regents level questions, which these were. So I hope you found this useful, and you utilize this to review for your last exam coming up in about 2 weeks. See you later, everybody. Oh yeah, subscribe to my channel.